So in this question here, we've got an owner of a fuel station. He believes that a third of the vehicles going into his fuel station are diesel vehicles. Now he wants to do a survey on this by doing a survey on the next 10 vehicles that show up at the service station. And he wants to know what values are evidence of this fact here to a 95% level. So he wants to be 95% sure in some sort of evidence-based mathematical survey that a third of the vehicles are diesel. So as this is a case where the vehicles turning up are diesel or not, and we've got a set number of tests for our survey, this is going to use the binomial distribution because we can assume each vehicle turning up is independent of the next or the previous vehicle. So the binomial distribution is x is distributed binomially n comma p, and these are our parameters for the binomial distribution. So in this survey here, n is the number of vehicles that he's going to be testing on, so n is 10, and the probability will be his starting position that a third of the vehicles are diesel, so p is a third. So n is 10 and p is 1/3. And we want to find the values of x which support his claim that a third of the vehicles are diesel. So to do that in this test, we're going to try and find the opposite of that and find which values are evidence that his claim is incorrect, and maybe there's some evidence to show that, and then we'll put in those values. So here's how we're going to do it. So first of all, evidence to the 95% level. So in our hypothesis test, what we're going to set up here, we want to be sure to what's called a 5% significance level for the alternative. So a 5% significance level. And we need to set up the null hypothesis and the alternative hypothesis in some sort of mathematical analysis style. So what we do is we set up the null hypothesis that the probability is starting position, that it's 1/3. Now he said there that he wants to know that it's the probability of 1/3. He hasn't specified that it could be more or could be less. So the alternative hypothesis is the probability is not 1/3. So as its probability is not 1/3, then it's a two-tailed test. So with a two-tailed test, we have to split this 5% significance into 2.5% on either end of the scale. So I'm going to show that in a graph now. So this will represent my binomial distribution, where x would be our number of vehicles from 0 to 10. So that will range from 0 all the way up to 10 up here. And the scale here with the probability that x equals x. Now, to find the centre or the mean of this distribution, we just multiply by n by p. So mu equals np. So 10 times a third is going to be 3 1/3. So if I put 3 1/3 there, that will be the most probable position. Obviously, binomial distribution will either get 3 or 4 because it's discrete data. So if I just sketched out a curve to represent that, although it will be staggered because there'd be 1, 2, 3 making little blocks, if I just sketch my curve, it would go something like this. So what we're looking for is the tails with 5% significance to look for our extreme values to show evidence against his hypothesis. So these here will be our rejection regions of the null hypothesis. So here we've got accept the null hypothesis. Here we reject the null hypothesis, and the same here as well. So we want to know what values of x that this line falls in. So what we need to do is work out a number for the lower end tail. So let's work out that first. So what we need to do is to utilise the function on our calculators, binomial CD function. And that will give us the probability x is less than some value x that we chose from 0 to 10. So as we're looking for the lower end tail, it'd be a suitable start to choose, let's say, 1. So if I did probability x is less than or equal to 1, put that into my calculator, I get approximately 0.1, which is around about 10%. So that doesn't fall into our value of 2.5%, which is half of that. So let's just write that down here. So each end of the tail should be 2.5%, 0.025. So that's too big. So let's try a slightly smaller value. So now let's try the only one that's left, which is 0, which is also the same, probability x equals 0, because that's all we've got, because it won't go to minus figures. That'll come up with 0.017, which is 1.7%. So in that case, the 0 is good. So now let's try in the upper tail. So in the upper tail, let's try a value, let's say 6. Probability x is greater than or equal to 6. Now our binomial CD function goes for less than. So we need to just calculate slightly different on that. So as it's greater than or equal to 6, we want to do 1 minus probability x is less than or equal to 5. So put that in our calculator, we get approximately 0.077, which is 7.7%. So again, that is going to be too big. That's going to appear somewhere here. As with this one, the 1, that will appear somewhere there. So that's inside our acceptance region of our null hypothesis. So now let's try the next one up. So x is greater than or equal to 7, which is 1 minus probability x is less than or equal to 6. So if we get that in our calculator, we get approximately 0.02. All the rest of the decimal places, I'll leave that for you guys to check out, but that's going to give us around about 2%. So that falls into our rejection region. So from that, we've now got our critical values. So here's our accept of the null hypothesis, and here's our reject the null hypothesis. So for accepting our null hypothesis, we've got the numbers 1 all the way up to 5 included. So if we just list them down, because they're all discrete values, obviously discrete distribution, so numbers 1 to 5 are going to be included. And here we'll notice x is greater than or equal to 6 is 7.7%, so 6 is also included. So if between 1 and 6 diesel vehicles turn up inside his in the next 10 vehicles at his establishment, then there's not enough evidence to reject that there's not a third of the vehicles are diesel in general, because this is only a sample. So now to reject the null hypothesis, we'll have the numbers that are left. So we'll have 0, and x is greater than or equal to 7, so 7 is included. So 7, 8, 9 and 10. So this one will be evidence that not a third of the vehicles that turn up are diesel. So that's his rejection values and that's his acceptance values. Okay.